This is the electronic component assembly guide. These are the related videos. These are the related kits. These are the tools that you need to assemble this kit. And these are the inventory of components including resistors, LEDs, transistors, LDRs, and other components. This is the circuit schematic of Dream Beam. R5 is the light dependent diode. When there is light, the resistance of the LDR or R5 goes to a few ohms. It means there is not much voltage drop between the two nodes of R5, and as a result, the transistor stays off. When the light source is removed, the resistance of R5 or light dependent diode goes to a few mega ohm. As a result, there is a significant voltage on two nodes of R5, and that voltage would translate to the voltage between the base and emitter of Q1, and transistor turns on. When transistor turns on, current starts to flow from collector to the emitter of the transistor, and that current results to LEDs to turn on. These are the resistors used in this kit. Your kit may contain either 4 bands or 5 band resistors. The color coding for 470 ohm 4 band resistor is this. 5 band resistor is this. 100 kilo ohm 4 band resistor is this. 5 band resistor is this. 1 kilo ohm 4 band resistor is this. 5 band resistor is this. And this is the diagram we can use to translate the color coding of resistors. These are the locations where the resistors should be placed on the PCB. We start by soldering two 470 ohm resistors. Then we move to 100 kilo ohm resistor, and then we install the 1 kilo ohm resistor. Two 470 ohm resistors, 100 kilo ohm resistor, 1 kilo ohm resistor. Bend the legs on the other side, solder them, and cut the excess legs. In this section, we solder the LDR to the PCB. This is the schematic of the kit, and the LDR is labeled as R5. The LDR acts as a part of a voltage divider that controls transistor Q1 on and off state. LDRs are non-directional, meaning it can be placed either way. The kit's LEDs might have negative influence on the sensitivity of the LDR. To keep the LDR away from LED's lights, we can mount the LDR on the back side of the PCB, and it fits better with the structural kit as well. Here we put the LDR at the back of the PCB, bend the legs on the other side, solder them, and cut the excess legs. In this section, we are going to connect the LEDs of the kit. This kit uses two LEDs which are connected to the collector of the transistor. Their power is controlled by the transistor. Here is the placement location for the LEDs on the PCB. LEDs have polarity, meaning they must be installed in the correct direction. There are different ways to identify the polarities of LEDs. The larger leg is usually the positive terminal. The shorter leg is the negative. Often LED casing has a flat edge on the negative side, and the most reliable method is look inside the LED. The smaller internal structure indicates the positive side. Place the LEDs into the PCB, bend the legs, solder them, and cut the excess legs. In this section, we install the transistor of the kit. This kit uses one NPN transistor. This transistor acts as a switch controlled by LDR to turn on and off the LEDs depending on the light level. Here is the location for the transistor on the PCB. The transistor must be oriented correctly. Notice the flat side of the transistor body. This must match the flat side printed on the PCB. Make sure the flat side matches the flat side on the PCB. Insert the component, solder the legs at the back, and cut the excess legs. In this section, we connect the USB power connector. The red wire goes to positive and black wire goes to negative. Solder the wires in place and cut the excess wire from the back. Dream beam could be used to control external modules. If you are interested to connect an external module to Dream beam, you can connect it to these outputs. Now the assembly of the electronic circuit of Dream beam is complete and we can test it now. Connect a power supply to the Dream beam. You can use a USB power bank to do so. When you cover the LDR, the LEDs should turn on.